Hello, here is another example of trig substitutions. This question has a factor of like x square minus a square. If that is the factor, we make the substitution a secant theta. In this question, a square is 1, that means a is 1. So I'm going to make the substitution x is just secant theta because a is 1. Dx is the derivative of secant theta, so secant theta, tangent theta, d theta. Let's try to work it out. In place of dx, secant theta, tangent theta, d theta. This one can be written as secant square theta minus 1 power 3. So you see I wrote power half and then power 3 separately. Usually I always say that work your limits as you go. But in this question, I'm going to work the limits at the end when I'm done with the whole substitution, when my final answer is back in the terms of x. Okay. Integral secant theta, tangent theta, d theta divided by secant square theta minus 1. So we know by Pythagorean identity, secant square theta minus 1 is tangent square theta. So this thing is tangent square theta. Square root of that is tangent theta. So here it is tangent cube theta. So we can see 1 power of tangent can cancel. So we'll have left with 2 powers in the denominator. This is secant theta by tangent square theta. I'm gonna try to simplify this in the form of sines and cosines. Let's see. Secant theta can be written as 1 by cosine theta. And tangent theta can be written as sine by cosine. So sine square theta would be here. And cosine square theta go up. Okay. 1 factor of cosine cancels. This is cosine theta by sine square theta d theta. This is kind of a trigonometric integral. We will have to make a substitution. Let's say u is sine theta. I'm doing because when you do the differential, sine theta's derivative is cosine theta d theta, which is already sitting in the question. Okay. So let's make the substitution. Cosine theta d theta is du. Sine theta is u. So that becomes u square. This can be written as u the power negative 2 du. Integral of that is easily done using power rule. So negative 2 plus 1, negative 1 by negative 1. So you guys notice I did the integral, but I'm not writing plus c. Because this problem is definite integral problems, we will have to substitute x values back at the end when we convert everything back in the x terms, okay? So this is negative 1 by u basically. But we need to first put it u back. So this is negative 1 by sine theta, okay? Now, the question is still not in the sine theta terms, it's in x's terms. So let's work out our substitution. We said x is equal to secant theta. That means cosine theta is 1 by x. If I want to see this in the right angle triangle strategy with angle theta, 1 by x is basically, cosine theta is basically adjacent over hypotenuse. So adjacent is 1 and hypotenuse is x. Using these two legs and Pythagorean theorem, we can give the other leg. That would be hypotenuse square minus the other leg square. We want sine theta. Sine theta should be equal to opposite leg, which is x square minus 1 divided by hypotenuse. This. So our answer is reciprocal of sine theta, basically negative. Negative is already there. X by square root of x square minus 1. Now we're back in the terms of x. Remember, we had the limits. We need to work out the limits here. Okay. So put the limits back. How do you work out the limits? We put the upper limit in the question. So negative 3 by 3 square minus 1 minus, but there is another minus, plus 2 by square of 2 square minus 1. So basically negative 3 by square root of 8 plus 2 by square root of 2 square minus 1, 4 minus 1 is 3. This should be your answer.